Hello, so today's lesson is the extend lesson on Unit 6. So we're going to start off today with some work basically on rounding and time. So first thing we have to do is work out a mean time and then do some work with that mean time afterwards. I suggest that you should use a calculator for this one. So I will get one now, keep it handy. You may use it later on as well. So when you're ready to start, pause the lesson, work your way through the question and return back to it to review your answers. Okay, sorry about that, that was just getting everything ready to go. So the first thing I did was I worked out the mean. In order to work out the mean, I converted all the times to minutes, because obviously you must always work in the same unit, and since some of them were only minutes, I worked in minutes. So I converted all of them into minutes, added the minutes together, divided by 6, and that gave me 72.166666 recurring as a mean. So when I was asked to round it, give your answer in minutes rounded to 2 decimal places, I got 72.17 minutes, which is rounded to 2 decimal places. Rounding to 2 significant figures gives me 72 minutes. And lastly, in hours, minutes and seconds, right, well the first bit is easy. I've got 72 minutes, that's 1 hour 12 minutes. But that leaves me 1.666666 recurring as a number to deal with. Now that represents a decimal fraction of a minute. So it's not that number of seconds, it's 0.166 recurring of a minute. So the first thing I need to do is take that decimal and convert it into seconds. I did that by multiplying it by 60. If I do that, I get 10. So that represents 1 hour, 12 minutes, 10 seconds. Part B then asks me which answer is most accurate. I think it's 3. I think it's 1 hour, 12 minutes and 10 seconds. That's very easy to understand. It's the easiest one to work with. The least accurate, I would say, is 72.17 minutes. We're not really that familiar with decimal parts of minutes, so it's not a number that's easy to understand. Also, it's slightly rounded where the others are actually quite accurate numbers. So I would say that the least accurate and the least useful as well would be 72.17. Okay, if you need to do any corrections, please pause the lesson now and return back to it as soon as you're done. So, next one is another piece of problem solving. Donna, Shakira and Mars are going out for a meal. They decide to put their money together. Donna's £13.50, Shakira's £18.20 and Mars is £22.75. So, we have a table which gives the price of everything that they ate. So use that table please to calculate the questions below. So pause the lesson and return back to it when you're ready to review your answers. So the first thing that I did to start off was I added together the 3 columns. Ultimately Donna spent £15.35, Shakira spent £16.15 and Miles spent £15.90. What's the total bill? Well, if we add all the numbers together we get £47.40. Could Donna afford to pay all of her own food if they haven't pooled their money? Well, Donna put in £13.50 and her meal came to £15.35. So no, Donna could not pay for her meal. They leave a tip of 10% of the bill. How much is this? Well, obviously we have to divide £47.40 by 10, which gives me £4.74. How much money do they have left? Well, to find out how much money they have left, the first thing we have to do is add up how much money they've got, which comes to £54.45. Altogether, they spent £47.40 and £4.74, which is £52.14. Sorry, £52.24. It is £52.14. If we take those two numbers away, we get £2.31, which if we divide by 3, we get 77 pence. So each person ended up with 77 pence returned to them. If you need to do any corrections, please pause the lesson, then return when you're ready. Okay, so this next question is on interpreting a graph. That just means taking the information from the graph and using it. But also there's a bit of rounding here, so take your time with it, but pause the tape now, work your way through it, return back when you need your answers reviewed. So, describe what happened to the UK population between 2010 and 2017. The total the population rose from 62.9 million to 66 million. What was the population in 2013 rounded to the nearest million? Well, we're looking at 2013. It's sort of there-ish, and so that's just over 64. It's definitely not as much as half. So that would be 64 million. In which years was the population 65 million to the nearest million? Well, depending on, every time I look at this graph, these look slightly different, but I think 2014, 2015 and 2016 all look like they could be rounded to 65 million. If you decided that 2016 shouldn't have been, I think that would be acceptable as well, because obviously a lot of this is all in the eye of the beholder. If it was a more, especially with graphs like that, if you had a more finely graduated graph paper, you could be a bit more accurate. So I would say 2 of those 3 will be absolutely fine. Okay, if you need some time to review your corrections, please do so now. Okay, bank statements show overdrawn balances as negative numbers. All of these students are overdrawn. 2 of the bank balances are missing. Mia owes the most. Write a possible balance in Mia's account. Lincoln owns the least. Write a possible balance for Lincoln's account. So all we're looking for here is 2 numbers written down that satisfy those conditions. Pause the lesson now and come back to it when you're ready to carry on. Okay, so here there are lots and lots of numbers, so all I've said is Mia owes the most. So her balance must be minus 72.32 or a bigger minus. So a smaller amount will be a bigger minus, so it could be 73, minus 73, minus 74 and so on, but it must be 72 minus 72.32 or a bigger minus than that. It can't be 72.31. Similarly, Lincoln's, who's got the least, so it must be closer to 0 than minus 5.82, £5.82. So it's £5.81 or closer to 0. It must be less than 0 because it does say in the question that all the students are overdrawn. So a number that is £5.82, minus £5.82, 81 or closer to 0 than that, but not more than 0. Okay, if you need to make any corrections, pause the lesson and return as quickly as you can. Problem solving. The prescription medicine doses are measured in grams and milligrams. A high-dose tablet of ibuprofen has 600 milligrams of active ingredient. How much is this in grams? A tablet with 600 milligrams of active ingredient weighs 24 grams in total. How much of the tablet is not active ingredient? Okay, you've got a little hint that tells you 1,000 milligrams is the same as 1 gram. So pause the lesson, return back to it when you're ready to have your answers reviewed. So working my way through here, I took 600 milligrams and divided it by 1,000 to turn it into grams, and obviously 600 divided by 1,000 is 0.6. So there is 0.6 of a gram of active ingredient in the tablet. So how much of the tablet is not active ingredient? Well, it's going to be 2.4 grams minus 0.6, which is 1.8 grams. If you need some time now to do corrections, please pause the lesson, return as quickly as you can. Okay, so our next area is some calculations on multiplication and division, and then writing down what they all mean. So pause the lesson and return when you need to review your answers. So let's go through this. 105 divided by 5. Well, 100 divided by 5 is 20. 5 divided by 5 is 1, so that gives us 21. 105 times 0.2. So that would give us 105 times 2, which is 210. And I need one number after the decimal point. So I've moved the numbers one place to the right. So that would also be 21. Incidentally, if you think about it, when you're doing stuff like this, remember that 0.2 expressed as a fraction is 1 over 5. So think about that as we're going through this. 425 divided by 5. Well, 400 divided by 5 is 80. 25 divided by 5 is 5. So 425 divided by 5 is 85. 425 times 0.2. 425 times 2 is 850. Divided by 10 is 85. So you should be able to see that there is a relationship here. So dividing by 5 is very similar, because this means 1 divided by 5 in another way. So this multiplied is the same as this multiplied. Then for part E, divided by 10 is the same as multiplied by 0.1, divided by 5 is equivalent to multiplied by 0.5, divided by 0.2 is equivalent to multiplied by 5, divided by 2 is equivalent to multiplied by 0.5, and divided by 4 is equivalent to multiplied by 0.25. If you need to write down any corrections, you may need to rerun the lesson a little bit to get everything. So pause it now and rejoin when you've finished. Five grams of grass seed covers a 10 metre by 10 metre square. How many square metres will 5 grams cover? How many grams do you need to cover a football pitch that is 110 metres by 60 metres? Okay, when you're ready, pause the lesson and return to review your answers. So, first thing that we do, we multiply 10 times 10, which is 100. So 5 grams of grass seed covers 100 square meters. How big is my football pitch? Right, well, 110 by 60, I'm going to multiply 11 by 6 to give me 66, and then I'm going to add on my 2 zeros to give me 6,600 square meters. Well, how does that help me? Well, I know that I can now work out how many lots of 100 square meters there are in that by dividing 6,600 by 100, which gives me 66. So there are 66 lots of 100 square meters in a football pitch. Each 100 meters needs 5 grams of seed, so 66 times 5 gives me 330, and that's how many grams of seeds that I need, 330 grams of seeds. Okay, if you need to pause to write corrections, please do so now. Return to the lesson as quickly as you can. So, a cereal box is 19.6 centimeters wide by 7.2 centimeters deep by 27.5 centimeters high. What's the volume of the cereal box? All of these dimensions are halved. What's the ratio of the volume of the small box to the volume of the original one? Okay, so again, this is probably a question that you need a calculator for. So when you're ready, pause the lesson and return to assess the questions in a minute. So we start by multiplying 19.6 by 7.2 by 27.5, which gives us 3,880.8 cubic centimeters. That's the volume of the large box. Now each of the dimensions are halved. So 9.6 divided by 2 gives us 9.8. 19.6 divided by 2 gives us 9.8. 7.2 divided by 2 gives us 3.6. And 27.5 divided by 2 gives us 13.75. So that's halving each of the dimensions. Then we multiply them together, 9.8 by 3.6 by 13.75, and that gives us a volume of 485.1 cubic centimeters. What is the ratio of the volume of the small box to the volume of the large box? Well, I started by finding out how many 485s there were in 3,880.8, and dividing one by the other, I get 8, which gives me my ratio of the small box, the original box, of 1 to 8. Notice in this question, if I'd have stopped here, I wouldn't have got the mark, and also the question specifies small box to original box, so it must be 1 to 8, it cannot be 8 to 1. You must put them round in the order of the question. Okay, if you need to do any corrections, please pause the lesson and return as quickly as you can. Eight kilometers is approximately 5 miles. How many miles is each kilometer? How many kilometers is each mile? Okay. So, again, you may or may not need a calculator for this, but pause the lesson and return to assess your answers. So, how many miles is each kilometer? Well, we know that 5 miles is 8 kilometers. So to find out how many miles there are in each kilometer, we do 5 divided by 8. So that gives us 0.625. So there's less than 1 kilometer. Sorry, there's less than 1 mile per kilometer, which makes sense. Then for the next one, we're going to do it around the other way. We're going to do 5. Actually, so I've written those down incorrectly, haven't I? That should be 8 divided by 5. And that should be 5 divided. I haven't. 5 divided by 8, sorry, is 0.625. 8 divided by 5 is 1.6. I'm sorry about the mess I've made there, but the answers are the same. 0.625. 1 kilometre is 0.625 miles, and 1 mile is 1.6 kilometres. Okay, if you need to do any corrections, please do so now. Okay, so this is quite an interesting question. Use suitable equivalent calculations to work out these questions. And the hint that we've got on the first one is multiplying by 3.5 is the same as multiplying by 7 and dividing by 2. The reason why it's the same is because 7 divided by 2 is 3.5. So this is the method we're going to use for each of these. We could do a long multiplication. That would work it out just as easily, but in this case we're going to do a slightly different method, and we're going to use a multiplication followed by a division. So do your best with these, and when you're ready to carry on, pause the lesson now, do your best with these, and when you're ready to carry on, return back to the lesson. Okay, so in my first example, I've been told what to do, so I'm going to do 3.5 times 62, so I'm going to multiply 62 by 7, which gives me 434, divided by 2 gives me 217, so the answer is 217. For the next one, I've got 1.6, so I'm looking for two numbers that I can make 1.6. Well, in my previous question, I saw that 8 divided by 5 gives me 1.6. So I am going to multiply by 8, then divide by 5. So 125 times 8 is 1,000. 1,000 divided by 5 is 200. So that's worked that one out. The next question, C, I've got 2.25. 9 divided by 4 is 2.25. So I'm going to multiply by 9, 848 times 9, and which gives me 7,632, and dividing 7,632 by 4 gives me 1,908. And then 1.5, I'm going to multiply by 3, divide by 2, because 3 divided by 2 is 1.5. So 4,682 times 3 is 14,046. 14,046 divided by 2 is 7,023. The next one, I'm looking to multiply by 1.8, and 9 divided by 5 is 1.8, so I'm multiplying by 9, divided by 5, so I multiply the numbers together first, then I divide, to give me 7,623. And the last one, and possibly the trickiest, well, it appears to be, but it isn't really, is this 606.25 times 488. Right, 625 is 1/16 of 100. Okay, so if you think about it, you've got 50, 100, a half of 100 is 50, a half of 50 is 25, a half of 25 is 12.5, a half of 12.5 is 6.25, so it's a 16th of 100. So I'm going to multiply by 100 and divide by 16. Now that may not sound very easy, but just bear with me. So obviously multiplying by 100, we start off quite easily because it's just 488 with 2 zeros on the end, which gives you 48,800. And now I've got to divide this by 16. Okay, let's have a look. How many 16s in 4? Well, there aren't any. How many 16s in 48? Well, you should have an idea now that 4 and 8 is 12, 1 and 2 is 3, so 48 does go into 3. And also it goes into 16, so 48, especially if you're a dart player, you'll know 3 16s are 48. So 48 divided by 16 is 3 with no remainder. So how many 16s in 8? There aren't any. How many 16s in 80? Well, we've come across the numbers of 8, 16, 8 and 5, and 16 and 80, 16 and 5 already, and we know that 80 divided by 16 is 5. So my answer, so that gives you 5, nothing to remain. I've got a 0, I've got to put a 0 there. So my answer is 3050. So even though that looked quite complicated to begin with, the way it worked out, it wasn't that bad. Now, for this question, I do understand that maybe you haven't got all of this one correct. You do need to write down these corrections, please. So rerun this tape. Make certain you've got corrections written for each question. Thank you. A film projected in widescreen has an aspect ratio of 2.35 to 1. How tall would the film appear if projected on a screen 16.75 meters wide? Okay, so pause the lesson, work out your answer, return to the lesson when you've got an answer to review. So, the ratio that we're looking at here is 2.35 to 1. So how many 2.35s are there in 16.75? Because for each 2.35 wide, there is 1 high. So we divide 16.75 by 2.35, which gives us 7.128 to 3 decimal places. It carries on for a bit, but I've stopped it there. And that's 7.1. So rounding it to 2 decimal places, I get 7.13 meters. So the screen is 6.75 meters wide by 7.13 meters high. Okay, if you need to write down some corrections, please do so now and return to the tape as quickly as you can. So, although not as visible, cars use gears in the same way as bikes. Different gear ratios, numbers of turns in the engine, number of turns of the wheels, make the wheels travel different distances for each revolution in the engine. In a typical car, each revolution of the wheels is about 2 meters, so we're going to keep that in mind. Explain why 6 gear is the fastest gear. And a revolution is a full rotation of 360 degrees, so it's a full turn, it's called a revolution. How many revolutions of the engine does it take to travel 1 kilometer in 6th gear? Okay, when you're ready, pause the lesson and return back to it when you've got some answers to review. Okay, let's go through my answers here. So I've said that the 6th gear is the fastest gear because it takes less of a revolution of the engine to give the wheels a full revolution. So for every 0.56 of a turn, so that's a little over half a turn of the engine, the wheels do a full revolution. Whereas in 1st gear, it takes nearly the engine has to revolve nearly 3 times before the wheels turn once. So if the engine turns 100 times, the 6th gear the wheels will have turned that many more times. So that's the reason why 6th gear is the fastest, because it takes less of a revolution of the engine to give the wheels a full turn. So now we come on to a calculation. How many revolutions of the engine does it take to travel 1 kilometre? Right, well, first thing, how many revolutions of the wheel does it take to travel 1 kilometre? It takes, we know that there are 1,000 kilometres, 1,000 metres in a kilometre, and the wheel covers 2 metres per revolution. So the wheel has to go around 1,000 divided by 2 times, which is 500 times. So every time a wheel revolves 500 times, the car travels a kilometre. Now, for every 1 turn of the wheel, the engine goes round 0.56 of a time. So how many times does the engine have to revolve for the wheels to go round 500 times? Well, it has to revolve 500 times 0.56, which is 280. So the wheels have to, for 500 revolutions of the wheel, you need 280 revolutions of the engine. Okay, if you need to write a correction, please do so now. Right, that gets us to the end of Unit 6. The only thing that remains is to do the final test. If you feel confident about doing the test now, that's fantastic. I wish you the best of luck. If you think, I might need to look at a bit more, please go back and check the other videos that you've been working on. Make certain you understand the information from 6.1, 6.2, 6.3 and 6.4. And best of luck, and I look forward to seeing you for the next unit. Goodbye.